Hi friends, welcome to follow up. Let's have a look at problem 560. Subarray sum equals K. This is an important problem because this problem can be used as a prototype problem to solve other problems or its variants. So as we have demonstrated in the previous 2 or 3 videos. So this can be regarded as a small summary. So in this video, again, we are going to demonstrate the strategy of using data structure to solve problem. So here we are given an array of integers called nums and an integer k. So we want to find the total number of subarrays whose sum equals to k. So here are 2 examples. So in example 2, so the output is 2. It's very easy to see the 2 subarrays are 1, 2, and 3 itself, right? So in the first example, so we can choose the first 2 ones, or we can choose the last 2 ones. The return is also 2. So before we analyze the problem, let's also look at the constraints. So first, the length of this list can be as long as 2 times 10 to the power 4, and the elements in the list can be positive, can be 0, and can be negative. So here k is an integer, so in between these 2 numbers. So with that said, we are ready to look at the code and also look at logic. So this problem, as we mentioned at the very beginning, is a prototype problem. So it's actually important for those interested to really digest this problem. So overall, we can see from data structure aspect, we use dictionary here. And from logical side, we could see that we are using partial sum, or we are going to use partial sum. So here, let me first write code and then explain the logic. So first, I'm going to initialize a result. So this variable is a counting variable, right? So counting variable, counting the number of subarrays with sum equal to k. So we are going to return its final state. So we are going to use a dictionary to do the counting. So we are going to store partial sum and the frequencies of the partial sum. So here we want to initialize it using 0. So if there's nothing, so we have partial sum 0, and then it appears once, right? So the main logic is the following, right? We want to find subarrays with sum k. So assume, right? So a subarray, so starting from 0 index and then ending at I0, right? So assume this has sum s1, as a partial sum. And then we have another one if we look at further, right? Further index, so up to I0, then I0 plus 1 up to say sum I, right? So they have partial sum s2, right? So if s2 minus s1 equals say k, it means that the subarray starting from I0 plus 1 and ending at I will have sum equal to k, right? So this is the logic. So here we explicitly use the sum. So we are going to do this. So first, I'm going to write the code and explain the logic, and then we do some slight modification, and then walk you through an example. So let's initialize a current. So this is the running variable for partial sum. And then let's iterate over the list. So in this problem, the index does not come into play explicitly, so we just iterate for y in nums. First, we want to increment the current variable, right? And then we want to check if current minus k is in dictionary or not. If this guy is in dictionary, right, it means if we use the current sum, current minus the current minus k, we're going to get k. Those frequencies, those k and the corresponding frequencies corresponding to the number of subarrays, right? So what we want to do is, so if current minus key in dictionary, so what we want to do is result increments by this key, right? Current minus key. So this is the main logic. And otherwise, we can, and also we don't, let's not forget to update the current sum. So we get this one, so we are going to update the frequency of this sum. So if we use the get function, if current is not in the dictionary yet, so its counting will be 1. So we increment by 1. So this increment by 1 is due to the current sum, right? Then we are ready to return the result. So this actually forms a solution format. So now let's first do a test before we do anything else. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the generic cases. So here in this if block, we can use a similar logic here, right? So what we can do is this. So we can use this one line, right? So what we want to do is result increment by d get current minus key. If the current minus key is not in the dictionary, so we're going to use 0. So now let's test again. And it passes all the cases. So now let's use use example 2 to give a walkthrough. Actually, both the two examples are not that representative. So walk through using example 2. So here, let's have a result is 0 now, right? The dictionary will be something like this, have 0 and 1, right? So if we look at the first number, right? So the current is originally 0. So the current will be current plus 1, that will be 1, right? So 1 does not in this dictionary, so we do not update the result, and then we just add this to the dictionary. So 0 appears once, and 1 appears once. And then let's look at the number 2. So the current will be 3, right? So 3 or 3 minus 3 is inside the dictionary, right? So it means that we need to update the result by the d get 0, 3 minus 3, 0, right? So this means that we result equals originally it's 0, right? So we plus 1 because the key 0 corresponding to result 1. So this is the current state of the result, and then we need also update the dictionary, right? The dictionary is 0, 1 and 1, 1. So now 3 appears once, right? So now let's look at number 3. So we get current equals 6, right? So 6, let's see, we are going to update the result by d get 6 minus 3 or 0. So this means that the result for originally 1, right? So we get 3. The 3 corresponding to 1, so we get 1. So we get 2. So then also you can update the result, but it's not important. So 1, 1, 3, 1, and 6 appears once, right? So overall, we're going to return 2 for this example. So that's basically about it for this problem. Overall, the 2 points are the following. First, we use data structure to solve the problem. So here, the data structure we used is dictionary. So that's the 1 point. Another point is that to aid the counting, so we used partial sum. So this is another aspect. So with that said, that's about it for this video. Thank you.